I assume that you all know what the problem is with ASCE 7 in connection with this seminar, and I couldn't find a better nutshell statement about this when I asked Mr. Don Scott, the chairman of the ASCE 7 Wind Effects Subcommittee. It's only for rectangular buildings, but we use it for other buildings because we don't have anything else. Interpreting ASCE 7 for other buildings other than rectangular buildings, there's always going to be some interpretation and some assumptions that you have to make. And unfortunately, probably a lot of outright guesswork. So we have to make sure that what we come up with is safe, that is adequately conservative. So we always have to err on the side of conservatism in the event of uncertainty. But we can't do this too much. We don't want to do it too much because the result can easily be uneconomical. And there are places in the code where, because of the nature of the code development and the need to envelope rectangular block buildings, there can be places where it's very conservative, and there are places we can look for ways to get around that conservatism when we have a real world building of a particular shape. So here's an outline of what I'm going to cover. And let me just start with this caveat. This is a huge subject. In one sense, it's bigger than ASCE 7 itself, because nearly every provision in there has to be interpreted for almost all real life buildings, anything other than a rectangular block. So that would take an awful lot of discussion to cover everything, and I have to limit myself to just a pretty narrow view of that and pretty limited in detail. So we're going to talk about, first of all, in the first part of this, the components and cladding issue, and we're really going to focus on the edge zone issue. And let me get my pointer here. If I can get the pointer. Okay, there we go. In connection with components and cladding, we're really going to focus on the edge zones, where they need to go, where you need them, where you might not need them. Then in part two, we're going to take a few examples of some unusual features. We're going to talk about holes and openings in buildings. We're going to talk about extra long structures. And I've got a very interesting case study that involves some internal structural issues. And then in the third part, we're going to talk about adjustment of loads from rectangular blocks to various real-world shapes. And we're going to do that with the aid of looking at some aerodynamic handbook data. So everything is focused, as far as ASCE 7 goes, on Chapter 27 on structural loads and Chapter 30 on components and cladding. There's a very important chapter, and of course it's my favorite chapter because after all I'm in the wind tunnel business, but we're not going to specifically address that. However, as you will see, I'm going to be using the wind tunnel as a vehicle throughout to get insight and help us make some adjustments and interpretation of the standard. So let's get started on part one, which is components and cladding and all about the corner or edge zones. Well, it's in order to do some interpretation of this, it's important to know what the cause of these edge zones is. And here's a very important figure here, which shows as the wind approaches from the left and hits this square block, you're going to have positive pressure all along the front wall. But at the corners, it separates. And this one especially, the separated area has some curvature to the flow and an area in here we call the separation bubble. And there can be very high negative pressure there.